Okay, this is the video tutorial for the test review for Module 1B on solving equations. There's two steps to this. They're solving multi-step equations without application, and then the formulating multi-step equations. So this one is just you're given the equation. This one is more you have to figure out what the equation is. Or it's not just your typical solving of an equation. Let's put it that way. All right, let's take a look at what we have here. There is a lot of multiple choice on the test. You should still be using paper and pencil though, so you can work out the answers and then you can carry and use a calculator as well for sure. The Desmos calculator will be the one I recommend. The Desmos calculator I've built in here just in case we need to do any little calculations as we're going along. So 9x plus 7 equals 70. Now we've got a little sketch pad here. So we can draw on here. So we should always start obviously with the question itself. And then notice we have variables here, but we only have one term with variables. So I need to move my terms, my constant terms away from the variables. So instead of adding 7, I'm going to subtract 7. So when we want to move something from one side of the equal sign to the other, we're just going to do the opposite. 70 take away 7. There is that calculator there, but I'm going to trust my mental calculator for this one. Remember, when things are next to each other like this, it means multiply. So 9 times x, instead of timesing by 9, then I'm going to divide by 9. That will cancel, and then that will give me my answer here, that x equals, and 63 divided by 9. We could use that calculator if we wanted to, but you can see for this one that it's 7. We won't actually be going quite as simple as two-step equations on the test, but this was our starting point in that first lesson to practice this idea of showing opposites, going down the page, lining up your equal signs, and all those little things. So we've included it just as that little reminder. 5y plus 3 equals negative 17. So we got some negative numbers here. Remember, the variable doesn't always have to be x. It could be any letter at all. So I got my variable here, so I want to start moving terms to the other side. So I'm going to take away 3 from both sides. As it says, add 3. Negative 17 take away 3. Some of you, when you do this in your head, go two negatives, make a positive, and come up with totally the wrong answer for this. So anything with negatives and anything you're not sure of, you should always check just to make sure. And then instead of timesing by 5, I will divide by 5. That will cancel. And negative 20 divided by 5 is negative 4. Similar sort of thing. Seems we just had an answer which is positive and one that's negative. I think this is our one where we have a fraction. So I got my variables on the left here. So I'm moving terms away from the variable just by doing opposites. Check. Cancels. And 8 add, oops, that's supposed to be 5. 8 plus 5 is 13. And then you can divide both sides by 2 instead of timesing by 2. And it's pretty obvious for this one with multiple choice answers. You can see that it is 13 over 2. Just remember, you can check on Desmos as well. So 13 divided by 2. It will give you the decimal if you need it. But also importantly, this fraction button here, when you click on it, it will actually check your fraction. Now for this one, it didn't actually simplify. But if, for example, I did something like 2 over 6, you would have a horrible decimal here. But more importantly, when you click on fraction, you can see that it's 1/3. So use your Desmos calculator, particularly for questions with division, because it will simplify your fractions for you. 2/3 t minus 9 equals 3. So this time the variable is the one that has the fractions. So we're just increasing in difficulty just a little bit. Minus 9 equals 3. So I want to move things away from the variable. So instead of subtracting 9, I'm going to go ahead and I'm going to add 9 to both sides. And 3 plus 9 equals 12. And 2/3 t means that I'm timesing 2/3 by t. So instead of timesing by 2/3, I'm going to do the opposite of timesing by 2/3, which is 2 divided by 2/3. And I'm going to do 12 divided by 2/3. So this will cancel, and so will this. And I think we've got a Desmos calculator here. Yes, we do. So 12 divided by 2 divided by 3. And you can see it leaves it as a fraction, which is perfectly okay, but you can see the answer here straight away. Now, I didn't use the divide button this time. I just used the slash symbol on the keyboard because that's sometimes a little quicker to type with, but you could certainly do it as before. And I think it was 18, so let's go ahead and select that answer. Now, this we kind of covered in our lesson 1b.4 when we did proportions as well. So this is just a single fraction. If you want to, you can certainly put 10 over 1 and make this into a definite proportions question. I'm not going to do that necessarily. I'm just going to focus on the fraction on the left-hand side. So I know the line on the fraction means divide. So if I want to move the 5 to the side, I have to do the opposite of divided by 5, which is 2 times by 5. So I'm going to times both sides by 5. Oops, don't have much room over here, so I'll just have to fit it in there. So this cancels, that's why we want to get rid of the fraction. So n plus 3 is what's left. And then on the right-hand side, 10 times 5 is obviously 50. And then I can take away numbers from both sides. So instead of adding 3, I'm going to subtract 3. And I think we can see from here that 50 take away 3 is going to be 47. And that's one of our answer choices. Now we're starting to move up to the questions where we got variables on both sides. So this is our three-step equations for short at this point. So I'm thinking while I see this question, I want to bring my variables to one side and I want to bring my numbers to the other side. So me personally, I always like to bring letters to the left-hand side. So this negative 7b is the one that I'm going to move. So I'm going to add 7b. Now be careful where you put it here. Some people are starting to put it like randomly in different places and then doing like negative 4 at 7. It's got to be a like term. So this has a b, this has a b. So make sure you line them up nicely underneath each other so you're actually doing them in the correct place here. So 3b plus 7b is 10b. Take away 4 equals, and then whatever we have left here, which is 36. Instead of subtracting 4, we can obviously add 4. And then work out what that is. So 36 add 4 is 40. And then we get into that last step. Instead of timesing by 10, I can just divide by 10. And if we need to, we can use a calculator as well. 40 divided by 10 is just 4. So I'm going to go ahead and select that answer. Don't need to put anything for explain your thinking. That wasn't actually supposed to be there for this question. More three-step equations. So negative 6z plus 20 equals 2z plus 60. So me personally, I'm going to bring my variables to the left when I got variables on both sides and numbers on both sides. So the opposite of 2z would be negative 2z. And I'm going to do it on both sides. And once again, notice I'm lining up my terms here, z's and z's together here. Be careful with negative 6 take away 2. Use that Desmos calculator if necessary. It should be negative 8z plus 20 equals, as it says positive 60, I'm just going to go ahead and write down 60. I can bring my numbers now across to the other side. So I'm going to take away 20 from both sides, leaving me with negative 8z on the left-hand side. 60 take away 20 is 40. And then the final step here, as we're timesing by negative 8, the opposite is to divide by negative 8. Now, I know some people got confused with that because they saw when we said opposites and they started to, oh, well, if it's negative 8, I need to divide by positive 8. The opposite of timesing by negative 8, it's the operation that you do the opposite of. So instead of timesing, you divide. What did I do times by? Negative 8. So what do we divide by here? Negative 8. So we get left with z, and 40 divided by negative 8. We can just use our calculator if necessary, and it will be negative 5. Okay, that's three-step equations. Then we moved on to four-step equations in lesson 3, where we have parentheses on both sides. So same setup, just write out the question first. Just make sure you got it copied exactly correctly. And then I'm just going to do my distributive rule. So this really falls under those PEMDAS questions. So whenever you see parentheses, you would always work out those first. So 5 times x, we just put numbers first and letters second, so 5x. And then be careful not to do just 5 add 2 here, or even just to copy down the +2. Remember, you are multiplying these. So 5 times +2 is +10. 2 times x, numbers first, letters second. And 2 times by 17 is 34. And the calculator is available if you need it for that. Now it looks just like those 3-step equations, variables on both sides, numbers on both sides. So I want to bring my variables to the left. So 2x, do the opposite, which is negative 2x. And line it up on the other side as well, so you've got like terms. 5 take away 2 is 3. Bring down the +10 and positive 34. I'm just going to go ahead and put 34 at this stage. Now I got my just variables, bring the numbers to the other side by doing the opposites. So instead of adding 10, I'm going to subtract 10 from both sides. 3x equals 24. I'm running out of room a little bit here, but I'm hoping we can just about get this question in. So instead of timesing by 3, we can divide by 3. And 24 divided by 3 is 8. Notice for this one, no multiple choice. Sometimes we're going to have that. So it says just enter the answer. So I'm just going to put 8. Sometimes it'll ask you to put x equals 8. Let's see what it allows for this one. Didn't seem to do much. What if I put 8? Not sure if this one actually has a check. Perhaps it doesn't. Perhaps when I look at my teacher board, I can see what other people's answers are. We seem to have the same slide here twice. Not quite sure what happened there. Sometimes we have to distribute and collect variables on the same side, like this example. Now, this is definitely one that people did have difficulty with. We're so used to having done opposites on some of these questions that we kind of forget why we do the opposites. So opposites when we want to move something from one side of the equal sign to the other side of the equal sign. So but unfortunately for this one, I don't quite have a little sketch pad, but I've written out the stages here so you can see exactly what's going on here, because this is my guided example. So here's the question. I can see parentheses. So I did -5 times x, which is -5x. Very careful here. You've got to do -5 times by -2. So don't miss that negative at the start here, which will give you +10, and you can equal 8. Now, here's where some people want to say, oh, look, I got 12, I got 10, so subtract 10, subtract 10. The only problem is the 12 and the +10 are on the same side of the equal sign. So for this, you're literally just working out what is 12 plus 10, which is obviously just 22. So you're only doing opposites if you want to move it to the other side of the equation, which I don't for this question. So when I have 2 variables on one side, or if I have 2 constant terms on the same side, I just go ahead and simplify, I just collect terms. And when I say 2, it could be 3 terms, 4 terms, whatever. If you have more than one of any particular term on either side of the equal signs, go ahead and simplify those first. And then from here, you can continue with the question. So I have my variable here, so I'm going to move my numbers to the side. Instead of adding 22, I would subtract 22. And then from here, instead of timesing by -5, I would divide by -5. -30 divided by -5 is 6. And I can select that answer. All right, so it says there's one for us to try here. So let's see how we can do. 6x plus 2x plus 3 equals 38. So I can see those parentheses in there. So that's what I'm going to want to go ahead and multiply out first. So 2 times x is 2x. Now notice the sign in front of the 2 on this one is positive. So I'm doing +2, times by +3, which will give me +6. On the last one, I think it was a negative sign, which can sometimes make the questions that little bit more difficult. Now, on this time, slightly different. I have 2 terms on the same side, but this time they have x's. So these are the ones I'm going to collect together. So I'm not doing opposite of +2, which is -2. As they're both on the left-hand side of the equal sign, I'm just combining these. So 6 add 2 is 8. Still have my +6 here. And it still equals, oops, that was a horrible 6 there, equals 38. Let me immediately do the opposite so I don't forget what it is. So opposites, instead of adding 6, I'm going to take away 6. So 8x equals 32. And then I can divide both sides by, divide both sides by 8. And 32 divided by 8 is 4. And wonderful, that's one of my answer choices. So I can go ahead and select that. There is a reminder on no solutions and infinite solutions. So you're not going to know when you start the question. It could look just like the ones we've been doing where you have parentheses, but you're going to get to a stage where you have the same number of x's on both sides. So they would cancel out and you just have the numbers. So does 3 equal 5? No, it does not. So the answer would just be no solution. Sometimes you get exactly the same thing here. You can see the left and the right the same here. You certainly have the same number of x's, so they would cancel. And then does 24 equal 24? Yes. So obviously you wouldn't pick the no solution one. But if it's exactly the same, then we say infinite solutions. Just a reminder why. You can substitute in any number into this formula and you're going to get the same answer because it's the same expression. It's just kind of written a little differently to try and disguise that. So different numbers, no solution. Same numbers, infinite solutions. And it's probably going to be one of these here. Let's have a little try here then. So I'm going to skip a little bit just to save me writing. 6 times 4 is 24. And there's obviously an x in this question. 6 times 2 is 12. 4 times 3 is 12. And 4 times 6x is 24. So what I noticed straight away is look at the number of x's I got on both sides. Both sides, it's 24x. So if I take away 24x from both sides, these are going to cancel. So does 12 equal 12? Yes, it does. So I know it's already between these two just because I have the same number of x's. So as I said, yes, obviously don't pick no solution. You would pick infinite solution for this question. If it was 12 equals, say, 112, but does 12 equal 112? No, I would pick no solution for that answer there. But obviously it wasn't that this time. Match each equation with the correct answer type. All right, well, we got a bit of a mix here. So we've got to figure out, do they have a solution or do they not have a solution? So let me just rearrange these a little bit so we can see what we've got here. We have some that have questions and let's see what we've got here. All right, so I've got to kind of put these into 3 groups. Are they have a solution, infinite solution, or no solution? So ones with the same number of x's, I know that's certainly going to be between these two. This has a different number of x's on here, so I'm going to link that into having a solution, but it doesn't ask me what the answer is. It just asks, does it have a solution? This has the same number of x's, so I'm going to put that there. 7x and 7x, that does 2. 2x and 2x, that does as well. And number equals a number, that's a special case. Number is number. This has 6x, but this has negative 6x. So this isn't the same number of x's. So this one definitely has a solution. And then let's have a look. Does 12 equal 12? Yes, it does. So I'm going to put that there. Does 0 equal 1? No, it does not. Does 10 equal 10? Yes. Does 5 equal 3? Nope. Does 2 equal 10? Nope. And does 5 equal 5? Yes, it does. So you can kind of see quickly after a while, once you're used to what's looking for, ones with different numbers of x's are going to have a solution and you can work them out. If you see the same number of x's and the same constant term, then you know this is an infinite solution one. Or this technically has a number of x's, it just has 0x. So 0x plus 12 equals 0x plus 12. And if they have the same number of x's but different numbers, then these would be no solutions, as you can see here. And you can actually check to make sure you got it right. Whew, that'll be embarrassing on my video if I actually got that question wrong. And then lesson 1b.4 was proportions. This is where we do the cross multiplying. So we do this times this equals this times this. Doesn't matter which one you do first. I'm just happen to do this one. I never put the variable first in the number. I always do numbers first, variables second, because I think that looks easier to do. And you can just check through the workings out on this to make sure. We've done questions already with parentheses, so you've kind of seen these a little bit already. There is one for you to try here. Just tell you, you're supposed to get 11. If you don't get 11, keep going, see if you can find where that mistake is and keep working. Just remember, you're going to put parentheses around these terms here. We just go back for a second. Notice there's no parentheses here, but there are parentheses here when you get to that question. And that's the first part done. Obviously, that's everything we have. The second section is more just the formulating of equations, so that will be a little bit easier. That concludes the video for the first part, though.